Hi all, very good evening. So we're going to learn very important subject in this session, that is C language. So you know what is the importance of C language and how it is going to play a major role, right? So for every language, this is the basic language to start with. So in that C language, I'm going to deal from the scratch, that is from basics to the advanced concepts. We're going to learn many programs in this, which are very important in terms of cracking your interview and getting placed into the companies as well. So to start with, in this C language, I'm going to explain you regarding introduction to computers. So first, what is a computer, right? So generally, computer is nothing but it is a term which is extracted from a word called compute, where compute refers to calculation. Fine. So computer is defined as an electronic device which stores the data, which manipulates the data, and which provides the information or a result in terms of your output. So what does these all things mean, right? So storage of data refers to the input or unprocessed data. So whatever the data you give initially, whatever the data you store, that is unprocessed. Then manipulation of data refers to processing of data, which means you're going to perform some calculations. Fine. And information or the result refers to the output or the processed data. So when you do some calculations, that is processing of data. Once you process the data, you're going to get this processed data in terms of your output. Fine. So in that you have concept called system. So what is system? System is defined as a group of peripheral devices attached to central processing unit. So you have CPU, for that some group of systems are attached. Okay. Now those systems are categorized into two types. So those are standalone system and network system. So the name itself suggests that what is standalone system, which is independent, which means no system is connected, no other system is connected to that system. Example, we are going to use our desktops in our home, right? So that will be a standalone system. Whereas coming to network system, in this, there are multiple computers which are connected to a single computer. So this is often called as the concept of client and server. So here we have the features of computer. So the first one is speed, second one is accuracy. Right. So what is meant by accuracy? Data without errors, okay, or any mistakes. So data should be accurate. Then memory, an area where data can be stored, and this is diligence, which refers to the patience. So repeating the same number of jobs for any number of times that can be handled in terms of your computer, right? So it is very diligent. Versatile refers to unique device perform different forms of operations or different jobs. Fine. So here we have the block diagram of computer. So everybody are familiar with. These are the basics to learn. So first, computer is going to have input device, right? Where it is going to have three, what you can say, main memory unit, control unit, as well as arithmetical logical unit. These three are a part of your central processing unit, and you have output. Right. So whatever the input you give, that will be just stored into your CPU in this memory first. Then afterwards, control unit will control your input output operations. Then arithmetical logical unit, it performs all the calculations or manipulations, and finally it will process the output and it will give the output in terms of your output device. Fine. So computer, when initially it was given, it was only with the concept of von Neumann architecture, where this is your von Neumann architecture. Okay, so you have the categories defined here. Memory unit. So this is main memory unit stores the data for temporary. That is when the system is switched off or if it is disconnected from power failure, data stored is in this main memory unit gets permanently deleted. Okay, so now you have the concept of control unit. Control unit controls the input output transactions or input output operations. And next you have ALU, which is arithmetical logical unit, supports to perform calculations and comparisons in data, right? So now in terms of memory, if I want to define, memory is defined as an area where data can be stored. It is divided into two categories, that is primary memory as well as secondary memory. What is primary memory? Generally, whenever you store some data, the first priority is given for this primary memory, which includes the concept of RAM and ROM, where RAM stands for random access memory and ROM stands for read-only memory. So this random access memory is often called as volatile memory, right, which is called as your temporary memory. So this data which is stored in this memory permanently gets erases when the system is switched off or it is disconnected with power failure, right? So RAM is also called as read-write memory. So since it's supposed to store the data, modify it and insert and delete the data. Now, ROM. What is ROM? Read-only memory, where data is stored in memory which is meant only for reading. Data in this memory gets stored at the time of manufacturing of the computer itself, right? So these are called as your predefined instructions. Now, ROM is further divided into the following categories: PROM, right? EPROM and double EPROM. Fine. So PROM, programmable random read-only memory, then EPROM, which is erasable, then electrically erasable. So now that is all about your primary memory. Now come to the point of that is secondary memory. This memory will be given the next priority for the storage of data. Okay, so first priority will be given for your primary memory. Second priority will be given for your this is secondary memory. Okay, so we have two types of secondary memory here: hard disk, floppy disk, and nowadays we have CDs, DVDs, then pen drives. Okay, all have come into the picture now. So hard disk, it is a secondary storage device where data can be stored permanently. So in primary memory, data cannot be stored for permanent, whereas in secondary storage, that is secondary memory, data will be stored for permanent. It is also called as read-write memory. It is stable device. Okay, floppy disk, it is also secondary storage device. When data gets stored, where data will be stored again in permanently in this, it is also a movable device. You can carry this floppy disk from one place to another, right? So floppy disks are derived into following categories, which is of size 5 1 by 4, 3 1 by 2, right? 3.5, that is 8. Okay, where storage capacity is 1.2 MB for particular 5 1 by 4th of what is that size, then 1.44 MB for 3.5 size, and 16 MB for 8 size, right? Now CD-ROM, which is of compact disk read-only memory, generally we see it is of 680 MB, 700 MB, 710 MB, like that. Okay, and finally you have DVDs, which is digital versatile or video disk, right? We have terabytes of memory as well on this DVDs. Now, generally, the memory can be measured in terms of zeros and ones. That is in terms of bits and bytes. Generally, we see zeros and ones. Okay, that is called as machine language. So when the input is provided by the user, then first the input gets interacted with inbuilt predefined codes, often called as ASCII code. You can see here. So this is all about your ASCII code. Okay, so what ASCII stands for? American Standard Code for Information Interchange. So here, these ASCII codes are provided with some 255 in number. So just see, for one character, you're going to have 1 byte, which is of 8 bits. So 1024 bytes equals to 1 kilobyte. 1024 kilobytes equals to 1 megabyte. 1024 megabytes equals to 1 gigabyte, and 1024 gigabytes equals to 1 terabyte, and 1024 terabytes equals to 1 octabyte. So this is how the memory will be measured in terms of your computer. Okay. Initially, when RAM was provided, it was with the capacity of 1 MB. Later, it was changed to 8 MB, right? 1 GB, then now 128 GB and more. Okay, the hard disk. Initially, it's supposed to store 1 GB, and afterwards 1.2, then 2 GB, 80 GB, 20 TB. Right now, it's very vast. Okay, now we'll start with the basic things here. So that is all we have learned about computer and all those primary memory, secondary memory. Now we just enter into the what you can say, the basic uh, things which we are going to learn. Okay, that is computer study, where computer study is divided into two categories, that is hardware as well as software. So hardware, again, what it will do, hardware is nothing but it consists of devices, input devices as well as output devices. Whereas software, it is categorized again into two types, which is system software as well as application software. So system software is also called as your operating system, right? Where this can be used by single user as well as multi-users. Whereas application software, it can be divided or categorized as languages and packages. So now again, these languages are in turn categorized as low level language, middle level language, as well as high level language. Okay. So you can see here, hardware, it is a study of physical components of computer, that is those components which a user can see and touch. Okay. Those are nothing but your keyboard, mouse, joystick, pen, scanner. All these you can see and you can touch them. Those are called as your, what is that, hardware, the components. Okay. And next you have your output devices. So you know what are the basic output devices. We have monitor. Okay, that can be categorized into two types again, monochrome as well as color monitors. Monochrome, which is nothing but black and white. Color, you can generally categorize them, right? So screen comprises of rows and columns, rows ranging from 0 to 24, columns ranging from 1 to 80. Okay, so now printer, this is also an output device. Okay, so you have letter quality printers, line printers, dot matrix printers, inkjet printers, laser printers, fine. So it is used to print the processed data onto the paper. So generally you give a paper and you'll just take the printouts, right? So that is a printer, you know that. Then you have software. It is defined as a collection of programs. So here comes the actual concept. So what is software? So generally we'll be asked question like you are doing your engineering in computer science, right? So you want to become a software engineer. So let just tell me what is a software. That is a question, the basic question, right? So software is nothing but it is defined as collection of programs where program refers to set of instructions and that instructions in turn include your input, processing, and output. Is that point clear? So software again categorized into two types. Okay, this is system software and application software. So system software, what is system software? The operating system, right? It's supposed to start the computer. Operating system is defined as one which creates the interface between the user and the computer. It is derived into two categories, right? Single user, multi-user. So generally, operating system, which is a bridge between the user as well as the computer, right? So whatever the language I give or whatever I type, that won't be understandable by the computer, that is machine, and machine what it does, that won't be understandable by the user. So in order to make this flexible interaction between the user and the computer, you're going to use the system software, or you can say that that is an operating system which plays a major role. Okay, so now we have single user operating system as well as multi-user operating system. So in single user name itself suggests only one user can interact with the system, like MS-DOS. Okay, disk operating system we have. Then you have MS Windows, which is of different categories, 95, 98, 2000, ME, Windows XP, Windows 10, 11, okay, 8, all those have come into the picture now. Then multi-user, where more than one user can interact with the single central processing unit. Example, you have Linux, right? You have Unix, Linux, Windows NT, then followed by Macintosh. So these are multi-user operating systems. Then you have application software. It is one which is dependent on system software. Okay. Again, it is derived into two categories, languages as well as packages, which we have seen in terms of a picture, right? The diagram. Now, let us learn languages, right? So what does this language do? So this language provide a ready-made area to writing the program where through those programs, data can be stored into the memory of a computer. Fine. Okay, so generally you have a language, C language. It provides editor where you can write some programs, right? That is called as an area. So this language provides the same. So there are three types of languages: high level language, low level language, and middle level language. This is very, very important question. What does C language comes under? I mean, what language does C language comes under? So it is middle level language. So why it is middle level language? Let us see now. So high level language, what does it do? Right. So this high level language always supports to write a program with the help of simple English. Name itself suggests, right? So I'm going to write a program using simple English, where that program can be easily understandable by the user because it is in simple language, but it is not understandable by the machine. Machine won't understand that language. Example, Pascal, COBOL, Fortran. These are your what you can say, the computer languages, right? Then you have low level language. High level language, name itself, I mean, you can keep in your mind that high level language starts with a simple English. Whereas low level language, this language supports to write a program with the help of predefined codes. So there are some codes which are internally defined by the system itself, the language itself, right? So that can be just defined by your low level language, where that predefined codes can be understandable by the computer, but user cannot understand. Now it is clear. High level language, user can understand, but user can, but computer can't. Right? Whereas here low level language, computer can and user can't. Is that point clear? Right. So example, you have macro assembler, MASM, and turbo assembler. So, in order to form the bridge between these two, you have a concept called middle level language, which is combination of both high level and low level language, which means the program can be developed using simple English as well as your predefined codes. Example, if you take C language, you're going to have the header files called hash include stdio.h. So this is your predefined code. Okay. In the same way, when you go inside the program, somewhere you're going to write printf enter a value. This enter a value is nothing but a simple English. Is that point clear? So you're going to use predefined codes as well as simple English, which is called as your middle level language. So it is combination of both. So I can say examples are C, C++, Java, C Sharp. These are related to .NET again. Right. So all these languages comes under your middle level language itself. So now we have the concept of translators. Okay. So what is a translator? Very, very, very important. Okay. So what does this translators will do? Translators which translate the programs which is in written in simple English to machine language and machine language to simple English, that is vice versa, right? So they detect any errors in a program that derived into three categories generally: compilers, interpreters, assemblers. Okay. Now this part is very, very important. Generally, I said for you, like you have high level language, low level language, middle level language. So just forget about this middle level language. First, you have high level language. So this is developed in terms of your simple English. I said that the simple English can be understandable by the computer, or sorry, this simple English can be understandable by the user, but computer can't understand, right? So low level language, right? It is developed using your predefined codes, which can be understandable by your computer, okay, and user can't understand. So in order to make this simple English to be understandable by the computer and this predefined codes to be understandable by the user, we have these compilers which comes into picture. Fine. So compilers, what they'll do, they'll compile the program, they translate the complete program from high level language to low level language, that is machine level language, and machine level language to your high level language. Right, high level language to low level language, or and low level language to high level language. So low level language is also called as your machine level language. Fine. Is that point clear? So this is about compute. What is that? Compilers. Okay. So compilers will provide a fast execution of program, that is known fact, right? So we have examples C, COBOL, Pascal, Fortran. Now next you have interpreters. Even they also do the same thing. They translate the program from high level language to same low level language and low level language to high level language. Then when compilers are doing the same thing, interpreters are doing the same thing. What is the difference between these two? That will be the question, right? So what it will do is just see, suppose I have first line, second line, third line of your code, or 5 lines, 4 lines, 5 lines of your code. Okay. So what, first of all, I'll go with interpreter. What interpreter will do? It will extract the first line, it will convert or it will compile that first line. Okay. Then after compiling the program or compiling that first line, it it extracts your second line and compiles it. After second line, it extracts third line, fourth line, fifth line, where the execution process will be in line by line position. So if it is 5 lines of program, no issue. But it is of 5,000 lines of program, then extracting single line converting that into what is that compiling that, okay, and giving the output, it takes much time, right? So that's the reason we use compilers instead of your interpreters, okay. So it is a step-by-step procedure of execution, okay, of a program, okay. So this is interpreter. So I use compiler. What compiler will do? Compiler will complete program, all the lines at once, all the 5,000 lines at once itself, okay. So next you have assemblers. So out of these two, compilers I'm going to prefer. Got my point, I guess, right? So and then you have assemblers. These translators supports to translate the program which is written in low-level language. So here, how you're going to compile, execute, and view the output of a program in terms of a C language is if you press Alt plus C, the program gets compiled. Or you can say Alt plus F9, program gets compiled. Or you can say F9, program gets compiled. If you want to execute the program, then you're going to say Alt plus R. If you want to view the output of that program, you can say Alt F5. You can see the output of that particular program. Okay, so this is all about, or you can see even Control F9 as well. Okay, till now you have learned all those things, right? So now let us start with the introduction to programming. Okay, so in that, the first thing we are going to learn is algorithm. Okay, afterwards we're going to learn what is flowchart. So these two are very important concepts to start with. First, what is representation of algorithm? What is an algorithm? First thing, it's nothing but a step-by-step procedure of solving a problem is called as an algorithm. Okay, algorithm is a sequence of instructions that are carried out to solve a problem or program, whatever it is. Okay, so we have some features of algorithm. First one is finiteness. Algorithm must terminate after a finite number of steps, right? So even if there are the program gets not it won't get terminate, right, within finite number of steps. I can say that there is no finiteness in that. Fine. So next is input. So an algorithm can have zero or more defined inputs. That is fine. So whenever I give out input, I'm going to get the output. So output, an algorithm must have one or more outputs. Then you have independent is one of the features. Algorithm should have step-by-step directions. It should be independent of any programming code. Next one is unambiguous, right? So it should be very clear without any confusion, right? So there should not be any ambiguity. So that is the main feature of your features of your algorithm, right? So then comes to the picture, what is flowchart? So flowchart is a graphical representation of a program, okay? Or it can be said as the pictorial representation of an algorithm, right? Is called as a flowchart. So everything, whatever the algorithm you're going to perform, that will be termed in terms of diagrams here, okay? Just see here. So we have symbols. This is your start symbol, which is oval. Start and end symbol will be in oval shape. Okay. Then you have process step, which if you want to perform some calculations, like C equals to A plus B, right? So you're going to have rectangle, then decision. See, decision is nothing but a branching statement. Suppose you're going to, that can be given in terms of a rhombus or a diamond. You can see here. So I'm going to take A and B values. If A greater than B, I'm going to take this path, right? That is true. If A is greater than B, right? If that is condition is true, I'm going to take this path and I'm going to print some value that is A value, right? If A greater than B is false, so it is going to write here false and you're going to print some B value. If A is true, A value will be printed. If B is true, B value will be printed. So here we are going to make a branching statement, or you can say this is a decision, right? You are taking decisions based on your true condition and false condition. That is the diagrammatic representation of that. Then connector. So connector is given with circle. Let us suppose in one page, I'm doing some operations like this. Start, then some angle, rectangle, then starts with some what you can say parallelogram, then start with some square or rectangle, whatever it is. So up to here, my page is completed, let us suppose. So I'm going to put connector here. In the next page, I'll start with the connector and I'm going to work with the remaining continuity of your algorithm or a program, right? So this is all about the connector. And last one is parallelogram. If you want to take any of the input you're going to write in parallelogram. If you want to get the output, you're going to write in the parallelogram. But if you want to do some calculations, then you're going to use a rectangle.